Hello scientific brilliant people, how are you? Today I am going to discuss about numerical problem number 1, dual nature of radiation topic, chapter Gujarat Board Standard 12 Physics textbook. Very classic problem it is, and you are being given a cesium plate whose work function is this. So I'm considering this as a cesium plate, and then the work function of the electron is given. But guys, I would like to tell you one thing, that suppose there are 3 electrons, electron number 1, 2 and 3. This is the work function of the electron on the surface. So where is the surface? There can be 2 possible surfaces, but I am shining light from this side. Say this is my bulb. So this becomes the surface, and this electron will have work function 1.9. But this electron will have more work function because I need to give more energy to pull it out, and this electron will have maximum work function. Correct? This is it. Now there is a metal plate like this one. This is a metal plate, and it is having positive charge on the surface, and the charge density is given to us as sigma, which is 1.2. There is a small printing error. This is 1.2 into 10 raised to minus 9 coulomb. Now we know that the electric field due to metal plates is given by E is equal to sigma by epsilon 0. If had it been sheet, then here 2 will come. This is constant, this is constant, there is no distance term. That means electric field is constant, and electric field constant means lines are parallel. Now suppose if I put a small electron over here, say this is my electron, right? Then this electron is at rest, speed is 0, and the kinetic energy is also 0. Now the moment I put it over here, electron, it will experience a force in this direction, and that force is equal to EQ. So E is the electric field due to the plate, that is sigma by epsilon 0. Instead of Q, I am going to write down E. This is the force, and due to this force the electron is going to get accelerated. Due to acceleration, its speed will increase, and just before striking the metal plate, its speed will become maximum, and its kinetic energy will be also maximum, that is half mv max squared. So earlier the kinetic energy was 0, now its kinetic energy is half mv max squared. So there is a gain in the kinetic energy. It is because the work done by the electric field of the plate is F into D. F is this one. This is the force exerted by the plate on the electron. So sigma by epsilon 0 into E. This is the force multiplied by the distance traveled, suppose from here to here, is D. Now this answer would come in joules, and if I want to convert this into electron volt, I'll have to divide this by 1.6 into 10 raised to minus 19. So this will get cancelled. Right. So the work done by the plate leads to the increase in the kinetic energy. So the increase in the kinetic energy itself is equal to the work done by the plate. And guys, if I solve this, sigma by epsilon 0 into D, right, and D is given in centimeters over here. So if I convert that into meter, and sigma and epsilon 0 value if I substitute, I get work done as 29.83 eV. This is the work done by the plate. This is the increase in the kinetic energy of the electron if it is at rest. But if it is already in motion, we have to add its kinetic energy to this one, right? So now we move on to the first case, and here this electron has work function 1.9 eV. Correct? Now we believe the light to be made up of photons. So this photon has energy E, that is equal to hc by lambda. So if I substitute the value of h as 6.65 into 10 raised to minus 34, then 3 into 10 raised to 8 divided by lambda is 490 nanometers, so 10 raised to minus 9. This again answer would be in joules. Again, if I convert this into EV, my answer would be 2.7 EV. And the work function of this electron is given to us as 1.9 eV. So this is the electron on the surface. So if you are given the value of work function, that is the value of the work function of the electron on the surface. Now I am supplying E energy, out of which some amount of energy goes in form of work function in order to pull out the electron. Rest is the kinetic energy. We are aware about this equation. So I am giving 2.7 eV. Out of that, 1.9 eV goes to pull out the electron. Rest is the kinetic energy. So if I solve, I get the kinetic energy of the electron on the surface as 0.8 eV. Now again the same story. This is positively charged, so the electric field is constant. So due to this electric field, the electron will get accelerated. This distance d is given to us as 22 centimeter. So the work done by the plate would increase the kinetic energy, and that work done is increase in kinetic energy that we already calculated as 29.8 eV. But additionally, it already had some kinetic energy. So the final kinetic energy, the total kinetic energy of the electron would be 29.8. That is due to the work done by the plate, plus you have 0.8 which it already had. So the total answer would be 29.8 plus, so this is 30.6 eV. This is one answer. Now since this is already having some kinetic energy, then your answer would be maximum. Now as we go inside, and if we take an electron which is inside, and I would take more energy to pull out the electron, so most of the energy would be going in removing the electron, so its kinetic energy will be very small. So if you go deep and deep inside, then this factor will become less and less, so the total kinetic energy will reduce. So total kinetic energy will be maximum for the electrons on the surface. So here is another such electron which is shown. So this electron has exactly the work function as that of the energy of the photon. So I am considering this photon, right? This photon we already considered, and its energy was 2.7 eV. Now I am considering an electron inside whose work function is 2.7 eV, which means when it will be pulled out, it will just stay stationary because its kinetic energy is 0. 2.7 we are giving, 2.7 needs to come out, so the kinetic energy is 0. Now again the same story, the positive, it is going to have the surface charge density positive, and the electric field is going to pull or accelerate the electron. There would be work done. That work done is increase in the kinetic energy, which we have already calculated, 29.8 eV. But the total kinetic energy will be this plus 0. So it is 29.8 eV, and this will be my minimum answer. Why? Because if I still consider an electron below this one, then this electron will have more work function than 2.7. So anyhow that electron cannot be pulled out by this photon. So that is anyhow not going to come out. So we have to consider two electrons, one on the surface whose work function is given, and another electron whose work function is exactly the energy of the photon. So hopefully guys, you have understood the entire problem. Please like and share my videos, and if you have any doubts, do comment in the comment section. Thank you for watching the video.